The first task, as I mentioned earlier, is going to be the classification task. Okay, so we need to define what a classification is. We have done this earlier. You remember we have taken the BBC data and then tried to figure out what kind of topics that we have in the corpus, right. In this case again, we are going to be talking about classification with respect to machine learning. But before that, I will just give you some little definition related to that, which I have not done earlier, and then move into the perceptron and then see how perceptron can be used to classify a few things. Okay. So, we know very well that the task of assigning predefined disjoint categories to objects, right. So, given a set of object, so I want to classify that this is a different class and this is a different class, right. It is a very simple explanation. So, we want to detect spam emails. So, this is something all email boxes have implemented. So, we should understand what a spam email is in order for us to really identify whether it is a spam or a mail that you really want to read. Okay. So, there are certain examples and parameters that are available for you to distinguish between the spam and the non-spam emails. So, one of the tasks that you want to perform is, this is something that we do very often, right. So, we are very good in terms of replacing mobile phones in every 2 years, right. So, we keep looking at the newer models and then try to figure out based on the budget which could be the best within that budget, and then what kind of reviews you have seen for those, and then based on the reviews, based on your friends reviews and so on, you finally pick up, right. So, this is something which can also be called as a classification problem. I want to find all the mobile phones which are less than 10,000 rupees and received 5-star reviews. So, my budget is only this, I do not want to go beyond that, but I want to do within this pick up 5 or 6 phones and then go through all the reviews and then find them. So, this is something which we want to perform. So, in this case what happens, there are e-commerce sites that provide you all the details in terms of click 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 and then you get to this, and then you also have reviews related to that. There are just 5-star reviews without any text related to that mobile phone, and there are reviews which are written in English. You want to read them and then find out what some unknown person had said about the review. So, this is again a classification task that we want to do. So, suppose if you are given about 1 GB of review data, right, which contains reviews about all phones in English text with respect to the mobiles, with respect to the features of the mobile, with respect to the price, all that in all English text. It contains data from, let us say, 5,000 to, let us say, 100K phones. Okay. And then it is a huge pile of text, and you want to classify that with respect to the reviews in terms of 5-star reviews, or you want to classify that with respect to the price, or you want to classify that with respect to the manufacturer and so on, right. So, this is something that you can perform using the classification task. So, what is that you require? You require some kind of a corpus that contains the reviews about all the phones. You should be able to extract a certain feature set from the corpus and feed that as input, and finally classify that based on what is asked. Okay, so, this is going to be using some kind of an NER. So, NER will extract the features for you, and then using the features you can classify. Okay. This is something that we saw, as I mentioned earlier, using some corpus where we have data related to sports, politics, entertainment or business. So, when you have taught the system to recognize these based on the corpus, when a new data is coming in, you want to find out whether it belongs to any one of these, right. And then you want to figure out whether a review of a movie is positive or negative. Now, without really looking at the dashboard, you want to really go read some reviews. Some people are very good in writing a review. So, you want to really go read that and then find out what that person has said about that and so on. Okay. Apart from that, you want to classify that based on what the review is all about, it is positive or negative. So, this is another type of classification that you would do in the natural language processing. Okay. So, let us give some simple definition for classification. So, supposing look at the figure at the bottom here, right. So, there are two classes, one with blue squares and then another one with red circles. It is very easy to draw a line, oops, and then say okay, there are two classes. Visually we can figure out that, but supposing if we have gotten the data with respect to all those points sequentially, right. So, where the points are mixed. So, we want the system to really draw a boundary and then tell us whether this point belongs to class 1 or class 2. Let us assume that this is class 1, this is class 2. And then how will it really draw the boundary and then say that anything to the left of the boundary is class 1, anything to the right of the boundary is class 2. Okay, so, for that we require two things. One is for the training sake we require the point and then we require to which class it belonged, right. So, what we have to figure out it based on the tuple that we have, we need to find out this line. Okay, assuming that we have a two dimensional points. So, the line separating or the plane separating these two classes is a 1D line. Okay. So, again what we know here, as I mentioned earlier, we know this set of points x 1. So, this could be x 1, x 2, x 3, x 4 and so on. Okay. Each one is like this. It is a two dimensional, it is a point, right. So, we have so many inputs which we are giving as input, and then we know to which class each point belong to, and we have to estimate this model, right. So, this is one of the tasks that we keep doing in the machine learning. Okay. So, here we have to create a model. When you create the model and when you are done with the estimation of the model, if you use g of x will also provide okay. So, this is your ideal model building exercise. Okay, let us see what we can do with this. Let us assume that there are a set of points which are given as input for the tuple, and then y is the set of features and x is the set of input. Okay. Then x belongs to the R square space and then is a vector, or you can call it as the set of observed variables. Okay. We know that x and y are related by an unknown function. So, we only know that x is related to y, x 1 is related to y 1, x 5 is related to y 1 and x 10 is related to y 2 and so on, if you have two classes like this. We know that they are related, but we do not know how they are related, right, and that is what we are going to be estimating. So, the classification exercise is to really estimate this model. Okay. So, the goal is to estimate the unknown function g. It is also known as the classifier function, such that g of x equal to f of x for all input that you have provided. So, this is a very simple definition of the classification model. So, using this model we want to roughly estimate g of x, and g of x will give you this decision boundary. Okay, let us see that how it is done. So, assume that we have a linearly separable x. So, it is very crucial, this linearly separable x in this case. Okay, this set of points, it should be the linear classification function implements the decision rule, that should be g, right. Let us be consistent with the notation. So, if you have a linearly separable set of variables and each variable is a two dimensional point such as this, it is going to give you a straight line that separates the point. So, we require two parameters for this. Fitting a straight line to a given data set requires two parameters. One is called W naught, other one is called W. Okay. So, in this case we call the W as weight, W naught as bias. The decision rule divides the data space into two subspaces, right. So, initially when the points are plotted, it is one single space. So, once we have estimated that function, it divides that space into two different subspaces, okay, using a boundary. So, the distance of the boundary from the origin is given by this relationship. Okay, so, note that W naught is the bias and then the one at the denominator is the norm of the weight vector. Okay, so, once you have the decision boundary, the distance from the origin is given by this relationship. So, this is your boundary, the blue line that you have here is your decision boundary, and then there are points on either side of the boundary, right. So, you take one point and then drop a perpendicular to that is going to be the distance of that point. Okay, so, this particular point that I am talking about from the surface, it is given by the g which you are estimating divided by the, or it is the ratio of the classifier function to the norm of the weight. Okay. And then this is your normal, this is normal, the W is normal to the decision boundary. Okay. So, we can call this as a line separating these two classes or a 1D hyperplane, since the input parameters are 2D, the decision boundary will be 1D. If the input parameters are in this space, and if you are defining this by x1, y1, z1, then you are going to be separating this by a straight line. I am sorry, by a 2D surface. Again, some more definitions, as I mentioned earlier. The goal of the classification is to take a vector x and assign it to n discrete classes C n, where n equal to 1 to n. So, in the previous case we had 2 classes. So, but you can also utilize this for n number of classes. The classes are disjoint and an input is assigned to only one class. So, this is something we should be aware of. The input space is divided into decision regions. Okay, the region that we had shown, right, the classifier had created that 1D line is our decision region. The boundaries are called decision boundaries or decision surfaces. So, one more thing also you may want to know, the points on the line where you will have the value of g x equal to 0. So, that means also let us say that this particular point is on the boundary and then the g of x equal to 0 for this point. And then for these points which are away from the decision surface or this 1D line, okay, such the points such as these, their values would be greater than 0. That is how we subdivide the input region into 2 different regions. And then in this case where the points are to the left of the decision boundary, we have g x less than 0. So, we kind of set a threshold so that the line is estimated based on the threshold that we are setting up there. Okay, I think this is the same plot in the enlarged space. Okay, so we have seen some examples, right, especially in terms of how these points are divided. So, one more thing I just want to explain before we go to the next one is the line that we have here, the decision boundary that we are talking about, it is estimated in an iterative fashion. So, initially when you start with, the boundary line could be anywhere, initially, since we do not know exactly the model. So, the model parameters that we have are w and w naught. So, we initially start with 0 and then given the input value and the kind of parameter estimation that we have, the line would be somewhere here. And then slowly and steadily based on more and more input that you are providing, it will start shifting parallel to this surface and finally settle down in this line. Okay. And then the distance from the origin is decided by, as I mentioned, the bias. Okay. And the orientation of that is given by the w. So, it could be points, some points could be like this, right. So, I want to have a line going like this from the origin too. So, it should be decided by the bias and also by this w with respect to the slope and with respect to the distance from the origin, and this is estimated in an iterative fashion. So, initially it will be 0 and then finally let us assume that these points are given by the equation A x, let us say 4.9 and then 0.75. So, when you reach this point, you will have a line of this type. So, I think the line would be this fashion if you have something of this type. Okay. So, how do we estimate this? So, this is estimated based on the error that we calculated. You remember we spoke about the target and the estimated value, right. So, let us assume that for this point we know to which class it belongs to, right. Let us assume that this is equal to 1, and then if the estimated value is -1, we know that we have to adjust W in such a way that it increases the weights for all the positive values, and if it is -1 and this is 1, we have to reduce the weights in the direction, so that it comes closer to the target value. Okay. So, again I am going to give some small examples here. Would you know what this would you know what these points represent? So, we have a 0 here and there is a point 0 and 0. Let us say this is x and y. I have used x1 and x2. We have x1 as 1 and then 0. So, we are talking about the decision boundary for an OR gate, right. Again, if you look at this, all the ones are on the right side of the decision boundary and the 0 is on the left side of the decision boundary. So, we are able to linearly separate this, right. So, this is and we have 1 only for 1 comma 1, rest we have 0, right. So, again we are able to linearly separate this point from the other points. So, there is no problem for us. Again if you want to estimate this, you can start by initializing the values of the parameters W and W naught and slowly and steadily estimate this particular decision boundary or estimate this model g of x equal to 0. Okay. So, decision boundary for this sentiment. So, you need to map it to our space, especially in the natural language processing, right. So, as I mentioned earlier, what are the problems that we are talking about in terms of the classification? This is sentiment. So, we have the sentiment analysis where we want to find out whether a given sentence has a positive influence or a negative influence in terms of the words that are present in the sentence, right. So, for example, if we have a set of words, they represent the positive influence and we have set of words that represent the negative influence. So, that means we would be able to again split the set of words which are in one input space into two different subspaces as positive region and negative region. So, all those negative words would fall to the left of the decision boundary and all those which are positive would fall on the right side of the decision boundary. So, this is one example. So, how do we do this? These are all words. So, how do I really provide the input? In earlier cases, it was so simple. We can provide the input as is in terms of the integers or real numbers and so on. So, in this case, we require some transformation of the input parameters. So, we will talk about that. There is one example that I will be showing later. Okay. So, again to explain that in the case of natural language processing, we can utilize these classification principles to decide whether a given sentence is a positive sentence or a negative sentence. So, it is possible for us to apply the same principle in the natural language processing as well. Okay. So, as I mentioned earlier, the variations of the W, right, in terms of the slope is decided by the Wj, and then the distance is decided by the W naught. Okay. So, there can be, you can actually write a program to show how the boundary changes during the iterative process. So, that is what I have shown here. And then this is another example where I have taken certain set of inputs, about 10 points, okay. And then I know to which class it belongs to. What I do not know is how to fit that. Okay. The fitment is not known, the fitment is learned during the iterative process. And then you can see that the line starting from here, this one which shows the plus here. So, I will use a different color, right. So, these points are my original points. So, this is where the target lies. Since I know only the relationship between the input and the output, so I start to estimate the classification function or the classifier using the iterative process. So, initially I start with 0 0, and then you see based on the input slowly and steadily it goes towards the original set of values. And then on the right side what you see is the trajectory through which the iterative process moved. You remember we have a target and the estimated value. So, let us call the target as y and the estimated value as y hat, right. So, when you start with y hat is not going to be equal to y that you are expecting. So, there is going to be some error, and we propagate the error back to the model and ask the model to learn that parameter, right. So, that is where W 1 keeps changing. You can see the variation here, right, for each of those. See how it varies for every iteration. So, once it is closer to the point or once it reaches the minima, we stop the iteration, or there is no more change that I can bring in. That means, the y minus y hat is very close to 0. That means, there is no more learning that I can provide. I have learned the system. So, that is where you can see that the iterative process moves in this direction and slowly and steadily reaches the final point. Okay. So, you can view this in terms of a one dimensional diagram. Okay. So, we started somewhere here, because this is the error we have. Maybe I will draw a different like this. We started from here and this is our destination. Okay. And then we moved here, and so on. If you do not have a differentiable function, it is not possible. And then at the end, it is almost flat. So, you do not have any delta x that you can move, and that is when it stops. You can think of this as a cone like this, right, and then you start your iteration from somewhere here and then slowly you come down and reach this point, and that is what is shown from the top level. This is the top view of this contour, which gives you the quadratic function that changes every time when you change the values of w and w naught. Okay. Is it possible to separate this? We have been talking only about linearly separable set of variables, right. So, in this case you know well that it is only separated by a curve and not by a straight line. So, I am going to give an exercise to you. You need to go and then find out whether it is possible to do this. Let us assume that this function, this is a piecewise linear curve. So, can I first take only this region and say there are points which lie to the left of it, to the right of it, and then next take another small piecewise linear region, another one and so on. So, you keep dividing this into various regions such as this, and then finally provide that the set of point that we have here on the right side of the curve belong to class 2, and then the one on the left side belong to class 1. So, is it possible using whatever approach that we had shown? So, this is an exercise for you. Okay. And then second one is, this is an XOR. Is it linearly separable? You know that we have A here, B here, 1, 1. So, we have points which are like these, right. So, is it possible to linearly separate this? So, if I draw a line here, this one is to the left of this. So, it is not right. So, can I draw like this? No. So, how do I separate this function? So, is it possible using the existing approach that we had followed to solve this problem? Think about it.